All right, we are going to be continuing with R1, which is still the algebra of basics, and we have already simplified expressions with exponents, and so now we're going to simplify expressions with radicals. So a radical is the symbol that is used to represent a root, and roots are the inverse operations for powers. So that means that if we have a power of 2 or something like x squared, the inverse operation for that is a square root. So if we have square root of x squared, that would just be x. Same thing for other roots. If we have x to the third power or x cubed, the inverse operation is a cube root of x. So cube root of x cubed would equal x. And if we have x to the fourth power, the inverse operation for that is a fourth root. And we can tell the kind of root it is by this little number. A square root doesn't have a number, but we know it's a inverse operation for squared or second power. Then we can have cube root, fourth root, fifth root. Anytime we do the same kind of root as the power, the radical and the power get rid of each other, and we're just left with x or whatever the base was. So we use that idea to simplify radicals. So let's first simplify some radicals that just have a number. When we simplify radicals, that means whatever's under the radical is as simple as possible, and there aren't any factors that can be taken out. So once we do this, I'm sure it'll look familiar from your previous classes. When we're simplifying square roots, which all of these are square roots because there's no small number or index written, we're looking for squares or groups of 2. So if we just have a number, one way that you've probably seen it before is looking at a factor tree or making a factor tree. Find any 2 factors of this number. So 45 can break down to 15 times 3. And 15 can break down more to 5 times 3. Now, we are looking for groups of 2 or any factors that are squared. So we have this, a pair of 3s. We have 3 squared. So when I see something like this, I can rewrite it as 3 squared times 5. Now, some of you skip writing it like this, and that's fine as long as you know how to simplify. And then since this 45 was under a radical, these are also still need to be under a radical. But now notice this one, since it was a square factor, it was 3 squared. The square root and the squared now get rid of each other, and we're just left with 3 without the radical. Now this, the 5 is not a squared factor. It's not 5 squared, so it doesn't simplify. So that 5 has to stay under the radical. So square root of 45 simplifies to 3 square root of 5. Now, the thing you might have done before without showing all these steps, anytime you have a pair, you know it goes on the outside. Anything that's left over by itself goes on the inside. All right, so 45 was a pretty small number and easy. Let's look at 216. That's a much bigger number. So let's find some factors of 216. It can be, again, any 2 factors. That's a bigger number, but I do know that 2 is going to go in it. So if you can't think of anything else, you can always use 2. So that would be 2 times 108. Same thing with 108. It's a little bit bigger, so I know I could use a factor of 2. So 108 breaks down to 2 times, that would be 54. Now 54 is one we're probably a little more familiar with. 54 breaks down to, it can break down to 6 and 9. And then 6 can break down to 2 and 3. And then 9 can break down to 3 and 3. Okay, so when we're doing this, we want a pair of 2s. So here's a pair of 2s, but there's still this 2 left over. It doesn't go in this pair. I only want a pair because I'm doing a square root. And then I have a pair of 3s and then a 3 left over. So when I write that, again, some of you might skip this middle step. That's fine. We have 2 squared times 3 squared. Those are the ones we have in pairs. And then we have a 2 that's not in a pair, so just 2 by itself and 3 by itself. Now this is still all under a radical because it's not just 216, it's square root of 216. So that means the squared factors, the square root of 2 squared and the square root of 3 squared, these ones both simplify. This one we'd have a 2 times 3 on the outside. And then this 2 and this 3 that are not squared would still stay under the radical. They don't simplify. Now, when you have two terms outside the radical, notice they are factors, so they're multiplied. So we would multiply these together. So we would have 6 square root of 6. That's what we would get for square root of 216. Okay. Now we can also do operations with radicals. We just have to remember how we can combine them. So on C, notice we are multiplying. When we're multiplying, we can multiply the outsides together. We could only multiply what's on the outside, and we can multiply what's on the inside. So if I multiply what's on the outside, 3 times 2 is 6. And if we multiply what's on the inside, 5 times 10 is 50. So we have 6 square root of 50. Now, sometimes we're done, but we're not done here because we still need to simplify this square root of 50. We always want to simplify our radicals if we can. So let's break down square root of 50. 50 breaks down to 5 times 10, and then 10 breaks down to 2 times 5. So I've got a pair of 5s, and then I got a 2 left over. So this is 5 squared times 2. But remember, this is under a radical. So square root of 5 squared times square root of 2. Square root of 5 squared. The square root and square get rid of each other, so we're just left with 5. And then the 2 stays under the radical. But that's not it. Don't forget, we have this 6 in the front. So this is still multiplied by 6. When the 6 is just in front, it's multiplied by the radical. Now that the 5 is on the outside, I can multiply those together, and we get 30 square root of 2. That's how we simplify by multiplying. We can only multiply together what's outside the radical and multiply together what's inside the radical. Okay, so next we have a subtracting. Adding and subtracting are the same. For both adding and subtracting, we need like radicals. And so right now, these are not like radicals. We have square root of 32, square root of 18. We need like radicals to be able to combine them or add them together. So in both of these cases, I need to simplify each of these radicals. So let's start with simplifying square root of 32. Don't forget that this has a 10 in front. This means 10 times square root of 32 when the 10 is just in front. So let's simplify the radical part first. So square root of 32, 32 can break down to 2 times 16. 16 can break down to 2 times 8. 8 can break down to 2 times 4. And then 4 can break down to 2 times 2. Okay, and so remember, we're looking for pairs. So we've got one pair of 2s, we've got another pair of 2s, and then we've got a 2 left over. So I can write this as 2 squared times 2 squared times 2. but they're all under a square root. So the squared ones, the square root of 2 squared and this square root of 2 squared, the square root and square get rid of each other. So we're just left with 2. Same thing on this one. So 2 times 2. This one, there's no squared, no power to get rid of the root. So that's going to stay square root of 2. Now these two on the outside can get multiplied. So that'd be 4 square root of 2. Now we're still not done with that because there was this 10 in front. So don't forget we're still multiplying by that 10. So this expression finally simplifies to 40 square root of 2. Now here, I have to simplify this expression, 6 square root of 18. So let's simplify the square root of 18. 18 can break down to 3 times 6, and then 6 can break down to 2 times 3. So I've got a pair of 3s and a 2 by itself. So that is 3 squared times 2. Now again, anything in a pair is going to end up outside the radical because the square root and the square get rid of each other. So this one we're just left with 3 on the outside, and then the 2 is on the inside, so 3 square root of 2. But we also on this one had the 6 in front. So this is still multiplied by the 6. So when I multiply that together, now that's going to give me 18 square root of 2. Good news is now these are like radicals because they both have a square root of 2. Now we can do the actual operation. The operation was subtracting. So now if I'm subtracting 30 square root of 2 minus 18 square root of 2, we needed the radicals to be the same. So when I subtract, the radical is going to still stay square root of 2, and I can just subtract the numbers in the front. 40 minus 18 is 22. So our final answer is 22 square root of 2. All right, we got a couple more to simplify. The difference on E and F. E is still simplified and radical, but it also has some variables, which we'll see how to simplify. And F, this is the only one that's not a square root. It is a cube root, which we can tell because it has that little 3 there. So that one we'll have to do a little different by using groups of 3 instead. All right, so let's simplify E. So I have 3 parts of this. I have the number, the X, and the Y. So I am going to simplify each part separately. So let's go ahead and simplify the number first. So the square root of 28 part. So I'm going to break it down just like I have been doing these the other with the factor tree. So this is 2 times 14, and then 14 is 2 times 7. So I have a pair of 2s and a 7 left over. So some of you just go right to putting the 2 on the outside because it's in a pair, and then the 7 would stay on the inside. You can totally do that, or you can write it out like this. So this would be 2 squared times 7. And since they are under a square root, this would become 2 square root of 7. Because on the squared term, the square and square root get rid of each other and just leave us with a 2. Okay, so that's the number part. Next, let's do the x's. So we can actually do this in the same way, not really writing a factor tree, but writing this out. We all hopefully know that x to the 5th means x times x times x times x times x. And so like I do with the numbers, since I'm dealing with the square root, I'm going to put these into pairs. So I got a pair of x's, another pair of x's, and an x left over. So if you like, you could write it as x squared times x squared times x. And because these are both under a radical, or all under a radical, the ones that are squared simplify. So on this one, the square root and the square get rid of each other, and we're just left with x. Same thing here, the square root and square get rid of each other, and we're left with x. Notice now these are not under a radical. This x, since it was not squared, is still under the radical. Now, I would write this since I have x times x on the outside. I would write that on the outside as x squared. And then on the inside, we just have square root of x. All right, now we also need to simplify the y to the fourth. So same idea, we can write out the y's in expanded form. Y times y times y times y would be y to the fourth. And if I put these in pairs, I'd have two pairs of y's. So I could write that as y squared times y squared. And since these are both under a radical, the square root of y squared, the square root and square get rid of each other. So we're just left with y from this pair. And then same thing on this one. We're left with a y from that pair. Notice everything was in a pair. There's nothing by itself. So there's nothing left under the radical. This would just simplify to y squared. Okay, now in my original problem, these three terms were multiplied by each other, 28 x to the fifth, y to the fourth. So they're still multiplied by each other here. So the way we're going to write this all together is, since I'm multiplying these together, anything that's on the outside gets multiplied together. So on the outside, I would write that as 2x squared y squared. And anything that's on the inside gets multiplied together. So I would write that as 7x on the inside. So this simplifies to 2x squared y squared, square root of 7x. And this is more simplified because the part under the radical is as small as possible. All right, last one like this on F. The difference here is that this is a cube root, which means to get rid of a cube root, the power that we want is x cubed. So that means I'm going to break this into groups of three. So I'm going to do it like I did on E. I'm going to do each part separately. So I'm going to do the number and then the x and the y separately. So square root of 24, or sorry, cube root of 24. I have 4 times 6. 4 breaks down to 2 and 2. 6 breaks down to 2 and 3. This time, remember, it's a cube root. So we're looking for a group of 3. So I have a group of 3 2s and then the 3 left over. Or in other words, I can write that in as 2 cubed times 3. And remember, these are under a cube root. So this time, a cube root gets rid of a cube. So the 2 cubed, I would get rid of the cubed part with the cube root, and then we would just have a 2 on the outside. And then we have a cube root of 3 left on the inside. All right, let's also do the variables. So next is x to the fourth. So that's x times x times x times x. And again, this is a cube root, so I'm looking for a group of 3. So I have a group of 3 and then an x left over, or x cubed times x. And so because those are under a cube root, the cube root and the cube get rid of each other. And so there we're left with just x from the group of 3. But this one is still left under the radical. So x cube root of x. And lastly, the y cubed. That one should be easy. I don't even necessarily have to expand that out because we know a cube root of y cubed, the cube root and cube will get rid of each other and we're just left with y. Okay, now I do have to put all these together. Remember, they are multiplied. So to multiply, I would multiply all the things on the outside. So on the outside, I have 2 times x times y. And then on the inside, I multiply, I'd have 3x. So, and remember, this is a cube root, so make sure you write the little index of 3. So 2xy cube root of 3x. Okay, so that's simplifying radicals. So hopefully that looks familiar to you. So now you are going to try a few practice problems.